Hello friends, we are going to see the next theorem in the similarity, the theorem of BPT. It's mean basic proportionality theorem. The statement of the theorem is given: if a line is parallel to the one side of a triangle and intersect other two sides in the two distinct points, then that line divide those sides in the proportion. We understand the given statement of the theorem helping with the figure. We take the first triangle DEF such that line M is parallel to the one side EF. Here a line M is parallel to the one side of a triangle EF and divide remaining sides. Now the side DE and side DF are the two remaining sides of a triangle DEF. Line M divide those sides in the two distinct points. Line M divide the first side DE at a point P and second side DF at a point Q. That is the given of our theorem. Now write the given first. In the triangle DEF, line M is parallel to the side EF and intersects sides DE and DF at points P and Q respectively. That is given. Now to prove of the theorem is the ratio between the two segments on the one side is equal to the ratio of two segments on the second side. It means dP upon P is equal to dQ upon QF is the to prove of the theorem. dP upon P is equal to dQ upon QF. Line M divide two sides in the proportion. It's mean in the same ratio. Now the construction of the theorem. Construction is draw segment QE and segment PF. Draw segment PF and segment QE. Now we get the proof of the theorem. Look at the figure carefully. We get some triangles in the figure. We take the first two triangles, triangle DPQ and triangle EPQ. In the triangle DPQ and EPQ, Q is the common vertex and their bases DP and P are the collinear. When the two triangles have one common vertex and their bases are collinear, it means the triangles are in the same height. It means height of that two triangles are equal. And we know that when the height of the two triangles are equal, then the ratios of areas of that two triangles is equal to the ratio of their corresponding bases. Therefore, in the triangle DPQ and triangle EPQ, using the property of the ratios of areas of two triangles, it means area of triangle DPQ divided by area of triangle EPQ is equal to ratio of their corresponding bases. It means dP upon P, because triangles having equal height, triangles having equal height. First equation. Similarly, look at the two triangles in the figure, triangle DPQ and triangle FPQ. In the triangle DPQ and triangle FPQ, P is the common vertex and their bases are collinear here. Therefore, it means that two triangles are also in the same height. And when the height of the two triangles is the same, then again we use the property of ratios of areas of the two triangles. By the property, when the height of the two triangles, ratio of areas of the two triangles with the common or equal height is equal to the ratio of their corresponding bases. Now we take thus in the triangle DPQ and triangle EPQ. Area of triangle by the property of ratios of areas of two triangle, triangle DPQ upon area of triangle FPQ is equal to the ratio of their corresponding bases. It means DQ upon QF, because triangles having equal height, equation number 2. But here the area of triangle EPQ is equal to area of triangle FPQ, because they have PQ is the same base and both triangles are in the parallel lines. When the two triangles are in the parallel lines, then the height of the triangles are equal. It means for the triangle EPQ and triangle FPQ, base and height are, base is a common and height is a equal. And we know that when the two triangles have same base and equal height, then the areas of the two triangles are equal. Therefore, area of triangle EPQ is equal to area of triangle FPQ. Triangles having same base and equal height, because triangles having same base and equal height. Equation number 3. Now look at the equation number 1, 2 and 3 carefully. Here in the left hand side of the equation, first we get the ratio area of triangle DPQ upon area of triangle EPQ. In the left hand side of the equation number 2, area of the triangle DPQ upon area of the triangle FPQ. It means in the left hand side of the equation 1 and 2, in the numerator, area of triangle DPQ is the common and their denominators, area of triangle EPQ and area of triangle FPQ, are different. When in the two ratios, the numerator is common and denominators are different, but the value of denominator, when the numerator is common and denominator are equal, now look at the ratios are equal. The denominator of the left hand side of the equation 1 and left hand side of the equation 2 are equal in the third equation. Therefore, from equation 1, 2 and 3, these two ratios are equal because they have a common numerator and the denominator of the two ratios are equal in the third equation. Therefore, area of the triangle DPQ divided by area of the triangle EPQ is equal to area of triangle DPQ divided by area of triangle FPQ from equation 1, 2 and 3. Equation number 4. Now from equation 1, 2 and 4, left hand side of the equation 1 and 2 are equal in the fourth equation, therefore their right hand sides are also equal. Therefore from the equation 1, 2 and 4 we get dP upon P is equal to dQ upon QF from equation 1, 2 and 4. And now as prove that the theorem of BPT, it means if a line is parallel to the one side of a triangle and intersect other two sides in the two distinct points, then that line divide those sides in the proportion.